seventh graders, let's compare theoretical probability to experimental probability. So in the last video you guys got some simple probability basics. Probability of an event is number of favorable outcomes divided by the total number of possible outcomes. Alright, so staying along the same principles of simple probability, theoretical probability is what should happen. Alright, so theoretical probability is what should happen. Experimental probability is what does happen in an experiment. Alright, so this is what does happen. Alright, and the two aren't always the same. Alright, what you'll find is that the more number of trials you do, the closer the two will become. Alright, so let's go back to the trouble example. Alright, so here's my trouble board. Alright, we've got a six-sided die, standard die. You push it, it pops up, gives you 1 through 6. Alright, so theoretical probability, alright, all these numbers should have the same probability of happening, the same likelihood of happening. So the probability of a 1 will be 1/6. The probability of a 2 should also be 1/6. The probability of a 3 will be 1/6. The probability of a 4 will be 1/6. They're all 1/6. I'm just going to write them down so you guys can see. Probability of 6 is 1/6. Alright. Alright, so the probability of any of those numbers should, in theory, be 1/6. Now, let's say I do 10 trials. Alright. Or even 6 trials. Let's do 6 trials. Alright. So let's do an experiment. I'm going to roll this die 6 times. Alright, so I'm going to keep track of how many times I get a number 1, a 2, a 3, a 4, a 5, and a 6. Alright, so we're going to do six trials here. Alright, so here's my first pop. Alright, I got a 6. Here's my second pop. I got a 2. Here's the third pop. Oh, another 2. My fourth pop, another 2. Whoa. My fifth pop, a 4. And then my sixth pop will be a 5. Alright, so we did 6 trials here, which, guys, isn't very many. Alright, if you're doing experiments, you need to do thousands and thousands of trials. Alright, the more trials you do, the closer theoretical probability and experimental probability will become. Alright, so using our experimental data, what's the probability of getting a 2? Alright, so I want to know probability of rolling a 2 using our experimental data. Well, my favorable outcomes happened 3 times. Alright, so I've got 3 favorable trials, all over 6 total trials. So according to my experiment, the probability of getting a 2 is 1/2. Alright, and who knows, maybe it is 1/2. Maybe one of my kids stomped on my board and my board became unfair, or my dice is messed up. Alright, who knows? Alright, my probability of getting a 1. I should have started with 1. Well, my favorable number of trials didn't happen at all, so that's a 0. All over 6 possible trials, so my probability of getting a 1 is a 0. Probability of getting a 3 didn't happen at all, so that's 0 as well. My probability of a 4, hey, there's one that matched up. That happened once out of 6 total trials, so that's 1/6. I don't need to simplify that. Probability of a 5 is also 1/6. And the probability of a 6 is also 1/6. Alright, so moral of the story, theoretical probability is what should happen. Alright, experimental probability is what does actually happen when you carry out an experiment. Alright, it's simply found by your number of favorable trials all over your total number of trials. Alright, so this should help you work on the IXL skill that I asked you to do in your challenge board. As always, send me any messages.